In this class, let's dive into partial differential of vector. Now we're told that if vector f is given to be 2ab I, this simply means I, plus open brackets a square minus 2b, close the brackets j, plus open brackets a plus 2b square, close the brackets k. Now we have to find the derivative, that is, this thing simply means partial. We have total derivative and we have partial derivative. Total derivative usually represent as this. You know, you might have heard about dy dx. Yeah, this is how we write total derivative. Why this one is partial derivative? So we are differentiating this vector f with respect to a, and we're also differentiating this vector f with respect to b. What does this simply mean? You know, if you look at this f, you will see that f is a function of a and b. That is, in this right hand side, we have a and b, right? This I, j, k, they just represent the directions. Okay, so f depend on this, the value of a and b here. If the value of a and b here change, the value of our f will change. So now we want to differentiate this f with respect to a only. That is, we consider only where there is a. If you look at this place, there's no a, this will change to 0. If you look at this place, there's a, we differentiate this. There's a here, we differentiate it, but this one will change to 0 because there's no a. But if you look at where there is combination of a and b together, you will differentiate a while you keep the remaining one constant. That is how we do it. Because it is partial, we are differentiating with respect to a only. Why the same thing applicable to b? Where there is b, if you look at this one now, there's b here, you differentiate it, but there's no b here. Here we change to 0. Here we change to 0. But here there's b here, you differentiate it. But here there is also a and b here. So you differentiate b, you keep these two a constants. So that is how partial differentiation occurs. So let's begin. The partial derivative of vector f with respect to vector a is equal to, as I've said, where there is a, you differentiate it, and where there is no a, you to change to 0. Now here there is a, but it's a mixture of a and b. As I've said, you will differentiate this a, keep these two constants. They will not turn to 0 because they are attached to this a. That is why they will not turn to 0. But any place that there is no a at all, they will change to 0. So here now we keep these two b constants. 2b, if you differentiate a, you know, this a is just like a raised to the power of 1. And in general method of differentiation, you use the power to multiply it, then subtract 1 from the power. That's how general method of differentiation work. You can watch my video on general method of differentiation. So when this one, when you use the one to multiply it, it becomes, it's still 1a. If you subtract 1 from the power, it becomes 0. You know, this will become 0. When this one becomes 0, it will not change to a raised to the power 0. And a raised to the power 0 will change to what? 1. So that is, this a will change to 1. Even if you use this one to, if you use the one to multiply this 2b, it will still give you what? 2b. Mind you that there's what? There's I. There's I. Okay, plus. Now let's look at this. We're differentiating with respect to a only. So if I use general method to differentiate this, you know, this a square. In general method, you use the power to multiply it. It becomes 2 times a, and then you subtract 1 from the power. You understand? So it becomes 2, that is 2 minus 1 will give you what? 1, a raised to the power of 1, right? So this 2 times a raised to the power of 1 will still give you a. So it will give us, everything will give us 2a, yeah? So here will give us 2a, but this one will change to 0 because there's no a at all here. We are differentiating partially with a only. So this will change to 0. Mind you, there's what? There's j here. So let me put j plus, I'm differentiating with respect to a only. A is present here, a is not here. This will change to 0. So if I use general method to differentiate this, it's like raised to the power of 1, as I've explained. So you use the 1 to multiply, it becomes 1 times, and you subtract 1 from the power. This will become what? 0. So a raised to the power of 0 will give us what? A raised to the power of 0 will give me 1. 1 times 1 will still give me 1. So this one will be, it will be 1. This will change to 0. 1 plus 0 will give me 1. So it will be 1k. And 1k is the same thing as what? K. So this will be k. So this, our final answer for the partial derivative of f with respect to what? With respect to a. Then let's look at the partial derivative of f with respect to what? With respect to b. The partial derivative of f with respect to partial derivative of b. Now, the reverse is the case. Here, you differentiate f with b only. So here, if you look at this, there's a combination of a and b. because A and B are mixed together here, so you take this 2A constant, you differentiate this B. But wherever B does not present, this place now is only A, there's no B here. So this should change to 0. This will change to 0 because there's no B here. But anywhere there's B and A, you just, since they are mixed together, just keep the other constant, differentiate B. So here now, I will keep this 2A constant, that is A will give me 2A. Now if I differentiate this B, this b, this b is just like raised to the power of 1, right? So if I want to differentiate this, I will use the power here, which is this one, to multiply it become 1 times. I will then subtract 1 from the power. If I subtract 1 from this power, that is minus 1, if 1 minus 1 will give me what? B raised to the power of what? 0. So b raised to the power of 0 will be 1, so it will be 1 times 1, right? So if I use the 1 times, this will change to 1 times 2a, it will still give me 2a. Mind you that there's what? There's I, so this becomes 2ai plus. Now if you look at this, you see that there's no b here. This will change to 0 because we are differentiating with b alone. Now if I'm to differentiate this minus 2b, because this minus belongs to this 2b, so here we have a minus 2b. Okay, so I will use the power of this b to multiply this minus 2. This will become minus 2 times the power of this b is what? 1. Then I will now subtract 1 from the power of b. That is, it will become b raised to the power. The power, original power is 1, minus 1 now. It will become b raised to the power of what? B raised to the power of 0. And b raised to the power of 0 will give me what? 1. 1 times this, it will still give me 1 times 1 will give me 1. 1 times minus 2, it will still give me minus 2. So this should give me minus 2. Mind you that there's plus here before. So it will now give me what? Minus 2, minus 2. Mind you that there's what? There's j. Good. Plus, I will still come back to this plus and minus here. Here now, I have a here, it will change to 0 because I'm differentiating with respect to b only. So, but here I have b squared. So b squared, as I've said, in general method, you use the power to multiply this b, it will become 2 times b. Now, I will now subtract 1 from the power, which will become 2 minus 1, right? So this becomes 2 times. Now, 2 minus 1 will give me what? 1. This becomes b raised to the power of what? Everything will change to 1. So this will become b raised to the power of 1. And b raised to the power of 1 will give me b. So 2 times b will give me what? 2b. So this will give me 2bk. So therefore, the partial derivative of f with respect to b, we have 2ai plus times minus will give me what? Minus 2j plus 2bk. 2bk. Yes, that is our final answer. Now, if you find this video helpful, please consider to subscribe, like, comment, share to your loved ones. Turn on the notification button so that anytime we upload video, you can get notified. Thank you.